Hi guys, in this video I am going to show you converting any decimal number into other number systems. Firstly, I am going to convert a decimal number into binary number. For example, I am taking a 2-digit number 81. Because I am going to convert this 81 into binary which consists of 2 digits, I have to divide this 81 with 2. When I divide 81 with 2, the quotient will be 40 and the remainder will be 1. Once I get the quotient and remainder, the quotient becomes the new dividend and I have to divide this new dividend with the same divisor again. 2 divides 40 with 20 and the remainder is 0. And when I divide this 20 with 2, I will get 10 as the quotient and 0 as the remainder. The quotient 10 becomes the new dividend and the new dividend is divided with 2 again. We will get 5 with remainder 0. And when I divide this 5 with 2, I will get 2 as the quotient and 1 as remainder. And the new dividend is 2 now. And when I divide this 2 with 2, I will get 1 as a quotient and 0 as the remainder. At this point of time, I will stop dividing because the quotient or the new dividend is smaller than the divisor. After stopping the division, I have to write down the remainders in the reverse order, starting from the MSB, the new dividend, till the LSB, the first remainder. So the decimal 81 will be equal to 1010001 in binary. Let us see few more examples for converting a decimal number into binary. This time I am going to take a 3-digit number 584. Every time I am supposed to write the quotient and remainder, and the quotient becomes the new dividend. The new dividend is divided with the same divisor until the new dividend is smaller than the divisor. Here 1 is smaller than 2, the new dividend is smaller than 2. So I will stop doing the division further and I will start writing all the remainders in the reverse order. And thus the binary equivalent of decimal 584 is 1001001000. If you understood this, let us move on to the next number, a 4-digit number 1926, and the division goes like this. Every time the quotient becomes the new dividend and I will divide the new dividend with the same divisor again and again until the new dividend becomes smaller than the divisor. We will start writing all the remainders in the reverse order to get the binary equivalent of decimal number. Hope you understood how to convert a decimal number into binary format. Now let us go to the other formats. We will be converting a decimal number into octal. Because we are going to convert a decimal number into octal, this time I am supposed to divide the decimal number with 8, as the octal number system contains 8 digits. So 8 divides 81 with 10 with a remainder 1. And 10 is greater than 8, so the division progresses. And 8 divides 10 with 1 times and the remainder is 2. 1 is smaller than 8, so the division stops and I have to start writing the remainders in the reverse order. So the decimal 81 will be equal to 121 in octal. Let's move on to the 3-digit number. I am going to take same examples. So the second number is 584 and the division goes like this. The decimal 584 is equal to 1110 in octal. Moving on to the 4-digit example 1926. The division goes like this. So the decimal 1926 is equal to 3606 in octal. Moving on to the next number system, that is hexadecimal number system. I am going to take same examples again, 2-digit number 81. This time I will be dividing this 81 with 16 as there are 16 digits in hexadecimal number system. 16 divides 81 5 times, the quotient is 5 and the remainder is 1. Because 5 is smaller than 16, the new dividend is smaller than the divisor. I will stop dividing further and so the decimal 81 is equal to 51 in hexadecimal. Moving on to the 3-digit example 584, the division goes like this. And 584 in decimal number system will be equal to 248 in hexadecimal number system. And the last example for hexadecimal number system, and the last example of converting a decimal number into hexadecimal number system 1926. The decimal 1926 is equal to hexadecimal 786. In hexadecimal number system, we are having digits like A, B, C, D, E, F. We have not seen those things in this example. So for that purpose, I am going to take one more example, 1946. Let us start the process of converting this decimal number into hexadecimal number. So when I divide 1946 with 16, I will get 121 as quotient and 10 as the remainder. I am not supposed to write 10 as it is while writing the hexadecimal number. I am supposed to write the equivalent digit. The equivalent hexadecimal number for the decimal 1946 is 79A. Hope you understood. See you in next video. Thank you.